Hello and welcome to PMCD MATHS Teaching. And this time we're looking at finding the mean from a frequency table and estimating the mean. Rationale is as follows. Okay, so hopefully this will make sense as I go through what we're doing here. This is the sort of order of teaching or things they should know, prerequisite knowledge. They should be able to calculate the three averages and the range, and hopefully know that the range isn't an average. We have a lot of students that tend to think that the range is an average. They pick that up because it's taught together. So emphasis on that when you're doing that is very important. I'll probably do a video on that one. Then we define the mean of data in a frequency table, and estimate the mean of data in a group frequency table. And let's say these back to back because it's almost the same thing, except for one slight tweak. I think when they're revising, it's good to be able to revise these things together. So if we separate them out in our teaching program, they can appear as two separate topics altogether. Okay, so there are quite a few things, little subtleties here to go into, but we'll get started with a more simpler one, which is the calculating find the mean of the data in a frequency table. So this is one example. You can use your own here. And just to say, there's questions down at the bottom here. They're not, I don't expect students to answer all those. If they're really there, some from extension as well. Okay, the mean is really what I'm focusing on here. But if they can answer the other question, if you found that easy and they can explain it quickly, then I'll let them have a go at finding the others, and keep those students going in that direction. So they've got some sort of challenge there for them. One other note, again, this is for newer teachers, really. I always think it's useful if you're creating PowerPoints or flip charts, as I'm using here, is to have before you've done the lesson. If you have got questions you want them to do, if you write that up on the flip chart or your PowerPoint. It means you're not fumbling around. It's much more slick for the lesson. And actually, you can save and adjust that from lesson to lesson as well. So I always have that there. Sometimes I put it out of sight. Do you allow me to do that? Not on this one, but you can put this out of sight or cover it up until you need it. Okay, so how do we find the mean of this frequency table? Now, look, as I said, there's what I would call practice for me would be that students, all they do is say, oh yeah, it's 1 times 2. 1 times 2 is 2. 2 times 11 is 22. 3 times 10 is 30. 4 times 1 is 4. 5 times 2 is 10. Okay, and they can do it. And you could be thinking, oh, they know what they're doing with this. It's quite. You seem to have sussed this straight away. A lot of the time they remember, as I said, they remember these shortcut tricks, and just lost totally the understanding of what's working and what's happening then. So when they get onto a more difficult problem where there might be something missing, for example, one of the frequencies might be missing, and they give, they say the mean of this data has a certain value, and say, oh, look, there's a frequency missing. Can you work out the frequency? They're totally stumped. And that's what I mean by not being flexible in being able to solve these problems. You've got the understanding. This goes throughout maths. I think we all know this. You've got the understanding, then you're much more able to be flexible in how you solve things because you know how the nuts and bolts work together. Okay, so aware of that. Beware of that. Beware of students who come in thinking they know what they're doing. Oh yeah, 1 times 2, 2 times 11, 3 times 10, 4, and they know what to do by multiply one, but they really can't explain why that's true. So there's a little bit of time on this section, and I'll always do this, even with a more able class, I will do this because it just gives me an idea, gives me a chance to assess their understanding of what's going on with a simple frequency table, because estimating the mean is going to use exactly those same skills. So what are we saying here? So the question I'll ask is, okay, I'll cover up the table, and I'll say, okay, this row here, I'll just keep this row visible here. What does that row, can you put that into a sentence? What does that actually mean? And you'd be surprised how difficult that is. Okay, so we do get lots of different answers there. They might just say, oh, the frequency is 2 and the number of stops is 1. Okay, now that's not very good English, is it? That's not going to give the person they're talking to understanding. So this might be an instance again where I might have I've actually got a telephone in my drawer, and I pull that out. I turn my back to them and say, okay, I'm on the phone. I can't see you. Okay, I want you to say exactly what you're saying there. And I'll build this answer as we go around the class. Somebody else might say, oh, I know I can give an improved an answer. And I say, well, can we improve on that, improve on that? What we're getting to the point is that this is telling us, okay, the frequency, we'll have to go back and redefine that, the number of times an event occurs in this case, or the number of times that something happens. Okay, so the number of cars which have a stop that stop once is 2. Now, even that is a bit of a convoluted sentence. So what I'm really getting towards is 2 cars stop once. So then I say, well, how many stops is that so far? And by the way, sorry, we've already gone through the fact that the mean is the total of all the data divided by the number of data pieces. The total of all the data divided by the number of total data pieces. So I say, well, look, we've got a column here. I'm going to call it total for now. How do I get that? Well, if 2 cars have stopped once, how many stops is that? Well, that's 2 stops. Okay. Now, don't talk about multiplying at this stage. We just go on. Okay, somebody else, give me a sentence to say what's happening in this row of the table. Oh, 11 cars stopped twice. So if 11 cars stopped twice, what does that mean? It means we've got 22 stops. And again, if they're struggling with that, you say 2 cars stopped once. You say, well, the data then would be like this. The actual data, the list data, 2 cars stopped once. That means we've got a 1 and a 1. So 2 cars stopped once. The next one would be 11 cars stopped twice. So we'd have a 2, 2, 2, 2, 2, 2. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And, you know, again, this gives the reason as to why we're putting this in a frequency table. There's so much data, but you know, if you really get stuck in understanding what to do, you can write this out. They won't want to do that. That takes too long. But you know, if they're really stuck, I actually make them. They don't know what to do, so we'll write out data. Get them to understand what they're dealing with here, rather than these shortcuts. That's 11 lots of 2, which is 22. And all of a sudden, it starts to make sense. Why are we multiplying these columns? Now, I really think it's worth taking time to go through that. And I said, if you need to get them to write the data out in a list, get them to do it. If somebody's looking for that shortcut they can't explain, been a bit, you know, resistant to actually thinking about it, so okay, well, what is the data then? I'll and help them out. Start and say, well, write all the data out and work it out. Now, it's quite key actually for this actually works actually when you're working out the median of the frequency table, especially for a low ability class if they're struggling to. It's quite tricky to actually find the median, I think. Them writing out all the data, and they can use their old median method. You know, it's a sort of you know, fail safe at the end if they really cannot get the method to find the median of a frequency table. But anyway, okay, so method, obviously we get the total number altogether. So we got 30, 4 and 10. So what does that give us? That's 24, 54, 58, 68. Let me just check that again. What we got? 30, 40, 44, 66, 68, yeah. Okay, so how do I find the mean? And again, this is where another misconception might come out. This is quite common. 68. How many numbers have I got? Oh yeah, I get all the data and I divide by the number of numbers. Okay, so there's 1, 2, 3, 4. There's 5 numbers. 68 divided by 5. 68 divided by 5. Okay, we know that's wrong, but rather than saying it's wrong, I say, okay, what does that give us then? You want them to reflect on what they're finding as an answer here. Okay, 68 divided by 5 gives us 13.6. And then I'll say, okay, again, what does that mean then? Can we put that into a sentence? Okay, and a lot of time they can't. Average number of stops per car, 13.6. That's what we're aiming for them. I mean, again, they'll fumble through this maybe to start off with. The average number of stops per car is 13.6. Well, how many cars in the original data stopped 13.6 times? None. So that's got to be wrong, hasn't it? And hopefully somebody will remember. And this is done at primary school, isn't it? So it just gets lost in memory, and the shortcut seems to remain there. We've got to divide by the total number of frequency, which is 13, 23, 24, 26. So actually that should be 68 divided by 26. Okay, 68 divided by 26, and that gives us it gives us 2.61. So actually, we've got to, is it possible? Number of any cars, 2.61 is in here, isn't it? Somewhere in here. That seems to represent the group. You know, that sounds reasonable, doesn't it? Okay. Now you can go into why 2.6. You know, you can't stop 2.6 times, but averages don't always give us a whole number of answers. It's telling us that, you know, closer to 3 stops than it is to 2 stops on average. But it's a way we can compare. We can compare 2 different Formula One races in this way and see what happens. And this might be analysis that is used by teams in Formula One to get an edge over another team. Can we reduce the number of pit stops and therefore, you know, have an advantage and win the race? So we've got the real life application there as well. Okay, so it's worth taking time, I think, over this very simple example because you've got nothing really disturbing you. It's all familiar, just to get that understanding as clear as possible. And you can follow that up with, you know, with a bit of practice, depending on how confident they are with this. If they're totally confident, you don't need to. I mean, these are all this past GCSE questions. You can get these. You can get these past GCSE questions from like Exam Wizard if you're on at Excel, and I'm sure the other boards have got something similar. Okay, so then after confident with that, we go into estimating the mean of group data, and I use something like this to start with. And again, a little hint here as well. I'm going to get the whole class to do this with me. We're going to do this together. So it looks like a lot of data, but that's what we're going to do. And again, although I can't do it on this software I've got at the moment, I would cover up these two rows, I should say, just and ask them, you know, ask so that they can't see what we're going to do straight away. So I print out one for each person, so we're not wasting time drawing tables in the lesson. I'd hold on to those printouts until we've discussed what we're going to do. Then I'll give the printouts, and then we start working on this. Okay. Okay, so yeah, emphasis again on reading the question. 130 boys sat the maths exam. So in this case, we've got to imagine here that we can't see these two rows here. Okay. What can we say? Can you give me, and I've switched the table around now. You can see it's a horizontal table rather than a vertical table. Number of boys, you know, could we give that another word? That could be our frequency, couldn't it? And that's what it means. So the number of boys, we've got 31 to 40 is 5. And, you know, that's, again, you're asking them, can you give me a sentence connecting the number of boys and Mark? The number of boys who've got between 31 and 40 is 5. The number of boys who've got between 41 and 50 is 14, and so on and so on. Okay, so how are we going to work this out now then? How are we working out a mean? Because we haven't got a mark for those 5 boys. What it means is we need to find a mark in this group we can use for those 5 boys. Okay, so what would be sensible? You know, when I ask, can I put these up? Some people say, oh yeah, use 40 because it's the biggest, or use, you know, 32. Might come up for all reasons. Some people will come up with using the midpoint straight away, and they might say it's 35. So I've purposely chosen one that doesn't work out as an integer here, just to show that we can't just, we actually have to find the midpoint a bit more precisely than that. But when we come on to it, saying, well, why would we use the midpoint here? What is the midpoint, first of all? So I might now reveal this row here. So what is the midpoint of 31 and 40? And again, a nice one, because this is something I like to run through every time we have to find halfway between two numbers, is to add together and divide by 2. So 31 plus 40 divided by 2 is 71 divided by 2, which is 35.5. So, okay, we can use the midpoint. What's the advantage of using the midpoint? Okay, so we're not just you know, flying through this method without explaining why it's happening each step. Okay, we need one value to represent this group because we don't know what all those five boys got. They could have got anything. They could have got 31. They could have got 32. We need one value to represent that group. Okay, we've decided we're going to use the midpoint, but why? Well, think about it. If we use 40, everybody got 31. We'd have an error for each person of 9 marks. Okay, if I use 32, okay, the maximum error is 8 marks, 32 to 40. But when we use the midpoint, the maximum error, okay, if it was 40, If somebody got 40, well, we'd be out in error by 4.5. And if 31, we'd be in error of 4.5. So our error will never be larger than 4.5. Okay. So we're also saying, well, why is it called estimating the mean? Well, again, we go back to saying, well, these 5 boys, we don't know what mark they got. So what we're saying is, those 5 boys, we need to give them a mark between 31 and 40. But what we're using is, we don't know what they've got, so we're using the best possible mark we can. So we're estimating their mark. We're saying that we're estimating they all got 35.5, because that gives us the minimum error. And that's why we do that. So we go along here, and we carry on. Okay, so once we've got that 40, so 41 plus 50 over 2, 91.5, which is 45.5. Okay, be careful. You know, sometimes I haven't changed the group size here. I don't know. I've done that. No, I haven't. Sometimes the groups are of different sizes, so just warn them about actually having this on this pattern that's 55.5. I mean, in this case, you can probably see it is because the group sizes are the same. Okay, once I've done that, I tend to do this. I tend to say, well, I don't need this anymore. Because now this question is just like the question we did when we looked at frequency table. We've got a mark or a data value, and we've got a frequency. Here we are. I've got a mark, which is 35.5, 45.5, and a frequency. So what do I work out for my group total here? 5 boys got an estimated mark of 35.5. That's 5 times 35.5, which is, I don't want to get this wrong, 177.5. 14 boys got an estimated mark of 45.5, and so on. And the overall total, instead of being a vertical column now, is going to be one of these. And again, we have the same question. What do we divide by here? So we're going to get that total, that big overall total. Okay, all of these added together. We want that overall total divided by, and again, we can get into that conversation. It's not 1, 2, 3, 4, 5, 6, 7, and you can show why. 5 by 7 and show that won't give us a value that is sensible, and show that it's the total frequency. And sometimes you can say that in the question, they sometimes give us the total frequency by telling you that. So it's a good check. Okay, so by putting these two together, you can see they're very, very similar skills, and these are sort of things then you can use. I can use these as in my quick 5 questions at the start of a lesson. I will use these on a simplified version of those. Where can this be? Where can this move off to? Well, the only thing is how the groups are represented. So we can look at inequalities, how they represent this. And so, yes, it would be an advantage to have done some work on what inequalities are. And I will be doing a video on inequalities at some point, which we can hook onto this. But essentially, they start to understand that the midpoint is add these together, divide by 2. So again, you'd have midpoint. So vary between vertical and horizontal tables. So they get practice for that. And they said, once you've got happy with that, you can then follow this up with looking at the modal value and the median group and the median value of frequency tables and group frequency tables. Okay, there's quite a lot in there. Just to make sure I've covered everything I wanted to cover on that. And I think, yeah, it seems quite simple, but there's a lot of understanding into that, and the clearer that is, the better prepared they are to build on that as a platform and deal with more challenging problems. Okay, I hope you found something useful there. If you're just teaching it for the first time, or if you've taught it before, hopefully maybe something new, something you haven't thought about. But if you've got anything that you want to add, that'd be great. I'd like to hear that. Just put that in the comments. Okay, great. Okay, well, thanks for watching, and I'll see you next time.